Okay, hello everyone. I left a few minutes just for everyone to join and get set up, but I think it's now 4 past, so it's a good moment to get started and get on the subject. So, welcome to this CompoSIDE webinar. With the main subject will be the ISO standards and the updates. It's been a long-awaited webinar probably for some. But fortunately for everyone, this webinar will also be recorded and you can replay it anytime through our YouTube channel. Later on, I will show you where that is and how to access it and what kind of content there is. So in the next hour, me and my colleagues sitting here next to me will present a few topics on the updated software, which also includes the ISO12215 Part 5 2019 standards, included in the YACHTScant module and the Yacht Designer subscription plan. I'm sure this is a big part of why you are attending today, of course. I see in the audience quite a few people who are experienced with CompoSIDE. They know, of course, the ins and outs of the software, but to those who are new to the software, in a minute, I will also introduce you to the basics of it, so that you get a bit up to speed. I will need to be concise and quite to the point on that, because we always want to have enough time to get to the main subject. For you to know, there's also a question and answer module in this webinar. At the end, we'll have some minutes to answer some questions from the audience. I'm sure we won't be able to answer all of them, but at least a few. If you're not able to pin your question, or if we don't answer them live, we can always catch up after and continue the conversation offline. I'm hoping everybody can see that Q&A button at the top of their screen. It's not so far from where you can raise your hand or switch on your camera and microphone. A lot of these are disabled for this webinar, but the Q&A should be possible. And you can post your questions anytime during the presentation, and at the end we will go through that. So let's switch slide here. So before we continue to the actual content, let me introduce you to our speakers. On the left, you see me. I take care of the business development on the marine sector for Structeam. And through the years, we have seen that CompoSIDE has a majority of marine-oriented customers. So it made a lot of sense for me to combine the sales activities and therefore try to best serve our clients in one or the other way. So in the middle, you'll see Marion. She's part of the Structeam team as well, and she takes care of all the organization and execution of marine projects, which means she's very well aware of all engineering challenges and updates that also can influence the content of the software, such as these ISO standards that we'll be presenting in a few moments. On the right, you'll see John. Many of you probably have worked with John before as well. He has been part of the development team of the software since the beginning. He's also a very experienced user and structural engineer, and has used the software to design, validate, and test many of his designs and projects we've worked on. So I hope that clarifies a bit the relationship between Structeam and CompoSIDE. CompoSIDE is a software developed in-house by Structeam and made commercially available and operating independently since 2014. So quite a few years now. And of course, there's still collaboration and still development of the software, and therefore working together to improve the service. You might have noticed a 3A logo at the title slide as well. This is because we've been collaborating closely to better understand the material implications and consequences of these ISO updates. So 3A has been very helpful to guide us and to exchange ideas on this subject. So let's quickly go to the agenda of today. Like mentioned, a small and brief introduction to CompoSIDE, just a brief recap of the key features so that people are on board of what they're looking at. Then Marian will follow me to explain the new ISO regulations, or at least some highlights of it. She has been studying those for a while, and it's not only because of the software, but also to discover how these affect the structures and designs that we see on a regular basis. She will elaborate a bit on the CompoSIDE changes as well, and how this affects your workflow, or how workflow can help you deal with those. At the end, John will also give a demonstration, a live demonstration of an example where these ISO updates in 2019 are affecting a design, and how CompoSIDE can help you deal with them. And right at the end, there will be then an update on the subscription plans and a moment for questions and answers. I hope this is the agenda you were expecting, of course. So let's start with why CompoSIDE and what is it? So CompoSIDE is software that helps engineers develop composite structures. It's indeed purely focused on composites, and it includes quite a few modules from beginning to end. So from selecting materials in a material library, defining your laminates and structures, until extracting documentation and a bill of materials. So the main objective is to allow engineers and designers to explore and test their laminate structures in a quick and sort of organized way, and centralized. In many cases, a heavier FEA software might be needed. In some cases, you could actually skip those, but this is supposed to be complementary. In any way, when going to a heavier FEA software, you will probably reduce the amount of iterations, and therefore the time needed to use those very costly FEA tools. Let's go into the next. So the centralized data management. This is something that is very key to CompoSIDE, because it keeps everything in one place. So all the material libraries and properties are always the same, and in the same software, which is web-based. It makes the comparison of materials, of course, quite a lot easier, but also the performance of each of those materials with different designs. You can compare things easier by just clicking for one or the other. You can hopefully avoid quite a lot of manual steps that are repeated over and over with every little change you make, because the workflow works upstream and downstream of the design process. In a second, that will be a bit more evident. This brings us, of course, to the option to streamline and implement workflows. So this enables the engineers to exchange data between themselves, colleagues, or third parties maybe also, but all especially between projects. So you can avoid working on independent files that need a lot of maintenance and manual intervention. You can enable faster and more efficient iterations, which are of course much needed in a design and engineering process to solve a problem, and allows a standardized approach. Some of you have already implemented that, but it increases, of course, the reliability of results by having a process that is optimized and corrected a few times. In the end, this will result in efficiency, in a higher efficiency of the team. Finally, if we go into the automated documentation, so by having all these features in one web-based software, it's possible to automatically generate documentation. So you have all the data there, and the software is able to extract all that data and distill it into a document, which can be used for internal review. It can be used to share with suppliers or collaborators. But anyway, it can also be used for certification, which is part of what YACHTScant module can do, third-party approval. So by having this automatically generated, you can save a lot of valuable time and possibly also frustration for quite a lot of engineers. That only by clicking on a button, you can get a document, and it all needs to be reviewed before sharing. So let's see let's say, more in practice, where we see CompoSIDE being a key element, because you can use it in many stages of the design process and also at different levels. So if we look, for example, a typical part is a preliminary design, where there is an idea and an engineer wants to check the problem, confirm the main drivers, and see and explore ideas around this. This could be, for example, a panel, a simple panel, but it could also be a beam. It could even be a complete laminate of a hull, the basic laminate of the hull. There's detailed design, where we can look more into the performance of a laminate, optimize things, look into the behavior of connections and local reinforcements. So this is more in detail to see how your structure or your laminate is working. We see also some advanced modeling. This is what I refer to with the light FEA version, where you can import geometries or use or generate geometries on the software and get the typical plots out for deflection and strains and all kinds of factors, just as a larger FEA software tool. Being able to do that, you can also translate it into a bill of material, just like I mentioned a moment ago, which can be used to discuss it with a supplier, a builder, or internally. It enables you to compare, for example, weights or usage and wastage factors and all kinds of material-related things that might be very, very useful to see at the beginning instead of at the end, when the design is actually already finalized. So finally, you export the document and submit that, for example, to a surveyor or reviewer for approval. This is where I want to end the brief summary, but I really hope this triggers your mind into thinking how this relates to your design practices and your daily challenges in this process. During the demonstration, John will also show the main dashboard of CompoSIDE, where it will become quite a lot more evident how the software looks like and how to work upstream and downstream in the design process. At this point, this was my part of the presentation. I will come back to you in a minute, but I would like to hand it over to Marion to go more into the ISO updates.
Thank you, Nico. Good afternoon, everyone. So as Nico just mentioned, ISO 2019 standard for design of small craft has been implemented in CompoSIDE. When ISO 2019 has been issued, this led to the cancellation and replacement of the first ISO 2008 edition and its amendments. And the ISO 2019, it's worth mentioning, includes major updates. What this slide presents is it gives you a summary of a few of the major changes which has occurred when we move from ISO 2008 to 2019, such as the positive addition of workboats to the rule. What I would like to do is let's run through how some of those changes impact vessel final design specification. So how does a change affect me in general? These slides focus on changes which are favorable to most if applied properly. And CompoSIDE is a tool which supports in achieving this. For example, latex curvature of a panel. ISO 2008 only accounted for single curvature. The addition of double curvature has been welcomed by designers of recent high-performance sailing boats, leading to more accurate curve panel design and behavior prediction. Acceleration and pressure as another example. An acceleration cap has been added and longitudinal pressure distribution has been modified following the industry feedback. Those bring better control of the maximum design pressure load and more realistic lower design pressure towards the aft end of the boat. This slide focuses this time on changes which can lead to a heavier design under the ISO 2019 rule, something we've spent some time looking at with instructing. Core specification, for example. Core specification of sandwich panel of small curvatures and low aspect ratio are most affected by the change, leading especially in the forward hull bottom of motorboat to heavier and thicker core being specified. Approach to help mitigating this issue will be discussed later on in this presentation. The importance of material database to prevent unrealistic failure mode, and how this is linked to the theory use. It is worth noting that the use of classical laminate theory is a correct approach when analyzing complex layup, including asymmetrical layup, as this is nearly always the case for hull laminate. And this theory is implemented in CompoSIDE. Classical laminate theory, as does FEA, require input of core out-of-plane and in-plane properties, which can be seen by many as an added complication. CompoSIDE database support designer in preventing unrealistic failure mode to be predicted due to incorrect material data input. One question you may ask, how does YACHTScant work? So let's start with the input. As for many software, this will start with the requirement to import a craft design specification and panel dimension within the software. The second thing, material need to be imported. Material can be selected from CompoSIDE material database or entered manually. Then the analysis is performed in the YACHTScant module, which has been updated to include ISO 2019. Factors and coefficients as per ISO requirements are derived. ISO, design pressure, are derived. Panel applied, design bending moment and shear force are then calculated, and classical laminate theory used to check each ply reserve factor and the overall panel reserve factor. This being done, ISO panel compliance report can be prepared upon request and downloaded. I mentioned earlier potential issue that could be encountered when designing flat panel with small aspect ratio. In the next two slides, I will focus on how this problem, which is related to ISO 2019 shear coefficient, could be mitigated. But first of all, let's look at the problem we are talking about. As just mentioned, for flat and small aspect ratio sandwich panel, ISO 2019 is over-conservative. This is illustrated in this graph, which gives you, on the y-axis, the shear coefficient, KSH, as a function in the x-axis of your panel aspect ratio. The panel which is analyzed here and the data presented for is a flat sandwich panel. The green curve shows the ISO 2019 derived shear coefficient, so using the rule. The orange curve, which is below the green curve, shows a shear coefficient for the same panel analyzed using finite element analysis. So this clearly indicates that core shear requirement with ISO 2019 is overestimated in most cases, especially sandwich panel. And for the example presented here, for the square panel, it is overestimated by 13.5%. So how could CompoSIDE help you in such situation? What could you do if you have a panel which you think is potentially could be close to passing, but just not passing, and is very likely to be due to this parameter? Within CompoSIDE, panel optimization can be easily done using the FESpace, and this is straightforward. Panel data already defined for YACHTScant analysis can be imported into FESpace. Iteration into FESpace is very efficient and reserve factor for your panel easily checked. I will now hand over to John, who will show you a work example illustrating some of the points I've mentioned through this part of the talk. Thank you.
Excellent. Thanks, Marion. So I'll jump into CompoSIDE now. Okay, so on the screen, you'll see CompoSIDE. So this is a generic environment which is used by us. You'll notice it's in a browser, so you can access it on any laptop anywhere in the world. You don't have to have any specific computers for high computation. So most designers will recognize a workflow in the layout of our modules as shown on the screen. So we work from left to right. First one is CMDB, where we have our material database. There are a few ways you can work with this. You can either use the material database that we provide to you. You can import your own materials. You can create materials in CMDB, and you can also export these to ANSYS or other softwares. Next, we have LaminaSpace, which is a CLT tool, classical laminate theory tool, which you create stack-ups using your materials, and this will give you your laminate properties, in plane, out of plane allowables, stiffnesses and strengths. Then we have section space, which is our 2D analysis tool. For example, if you're analyzing strength of beams in 2D, whether you're analyzing the midship section for global bending and global stiffness, this is the tool that's very useful for that. Next, we have FESpace, which is a 3D finite element analysis tool, where you can analyze beams and panels, keel grillages, basic panels, like we'll show you later. The next module is YACHTScant. So this is our yacht design tool. You can analyze vessels against ISO, both 2008 and 2019, and GL requirements. The next two modules I'll mention are BOMGen and ReportSpace. So BOMGen is a bill of materials generator tool. It grabs all of your material data from your previous modules, compiles it into one database, applies usage factors, wastage factors to give you a as designed weight and a weight of materials that you would order from your supplier. The next one is a reporting tool. So it's automated reporting, grabs all of the data that you have previously from LaminaSpace, Section Space, YACHTScant, and BOMGen, and compiles it into individual reports based on the templates that either we supply or you can set up yourself. So as this is a YACHTScant dedicated webinar, we'll jump straight into YACHTScant. And you'll see here that I have a vessel, a 40-foot powerboat. Now, on the first screen, you have very familiar inputs. Most of these will be very familiar to all of you. There's a few extra inputs that you have to put in, which are very specific to ISO 2019. There are a few other parameters in analysis setup. So in here, you've got your KAM and KBB factors, which are brand new for the ISO rules. So this outlines your analysis methods and your boat building factors. So from the rules, you can override these values, which we've put as 1 by default. All of the other factors are compliant with 2008 and 2019. So a typical workflow, if you were checking an existing vessel that you wanted to get certified in 2019, is pretty much the same. I'll show you a quick example here. So I have a hull bottom panel here, a very square panel. So it's 1.2 meters by 1.2 meters. A very flat panel as well, very small curvature. And when I put this panel in, I realized that I was getting quite a few failures. So in 2008, previously I'd used sandwich panel theory. But now as we're using classical laminate theory, I can see that I've got a few failures here in bending of my panel, which is quite strange. What I did is I looked at the bending moments in LaminaSpace, and realized that it was the core failing in tension. Now, this panel has a balsa core, which I wouldn't expect to fail in tension. So we've been discussing with 3A, and we've updated the in-plane allowable strains to what they would be in reality. Previously, in 2008, this wouldn't have been considered, as it only takes into account the shear force on the core. So in CMDB, I updated these in-plane allowable strains, and you can see here I have sufficient reserve factors in 2008, which are consistent with what I was getting before. Now, in 2019, I can see that my core shear on my short and long edge are now failing. Marion pointed out earlier that the 2019 rules are very conservative for very square and very flat panels. Now, I believe that 2008 was probably about right, but I want to check this and make sure that this 0.95 isn't reality. So using Marion's workflow from earlier, we're going to use FESpace to analyze the actual shear force distribution along the panel. So in FESpace, I can create a new model, give it a name. Okay, so there's a few ways you can create geometry within FESpace. You can either create geometry using the sketch tools. You can import step geometry, or you can use our panel wizards, which is very, very quick to do for simple panels. So I'll use the panel wizard to create this panel. So I can create the shell from template, select the type of panel. So it's either a curved or a flat panel. As this is a very flat panel, we'll choose flat panel, put in the length and width, select the laminate, which is already from the laminar space. And in loads, I can choose the fixity and the design pressure. So I can choose fully fixed around the perimeter, as ISO assumes. And I can put in the pressure, which I grabbed earlier from YACHTScant module. Okay. So here we have a model that's ready to run. I'll give you a quick show. So we've got a pressure applied to all the surface, and we've got a boundary condition that goes around the whole perimeter, which is fully fixed. So if I calculate this, it will then package it up, send it off to the server, calculate the results on the server, and then bring me back a results file. So there's no heavy work done on my laptop. So here we can see automatically the displacement plot of the panel, which seems fairly normal. But I want to focus on just the strength of the core. So I'll go into the reserve factor of the shell, focus on the out of plane shear failure type, and then calculate. And I can see that I've got quite a high reserve factor in core shear, which is on this edge here, which is very similar to what we have on this other edge here. So I'm very confident that my panel is now passing with 2019 rules. In reality, I'm not worried about this panel. So that gives me quite a bit of confidence. Good. So YACHTScant. So another benefit of YACHTScant is that you don't have to spend time putting together reports. With a right click, you can create a YACHTScant report, which will compile all of the data within your vessel. You can see how I've only got a few panels, but you've got panels and beams that will add together. So I'll name this ISO report. Choose a report template, so I'll choose 2019. So it grabs the 2019 values, hit save, and it's just collating all of the data, allowing me to export to a PDF. So if we just take a quick run through of the report, So we have an issue log. So each revision you can control, a very good way of tracking when things have been issued to the customer or reviewer. An overview of the vessel, your material properties, your laminate stack up and your laminate properties, through your panel details, your beam details if you have some, through to your result summary with a conclusion whether it passes or doesn't pass the required criteria. Okay, so we'll jump back into the presentation. Again. Good. So just a quick summary of what we went through. So we reviewed a panel which was appeared to be failing with the CLT analysis. We then reviewed the in-plane balsa core properties after some discussion with 3A. We then made sure that the panel was passing using 2008 rules, which we were expecting. Then we had to deal with the panel appearing to fail in 2019 due to the core shear factor and distribution of the panel. We reviewed in FESpace using FE models to actually check the actual shear forces on the panel, which gave us some confidence that the panel was okay. And then we generated an automatic report from YACHTScant. So I'll hand over to Nico, who will run through the updated subscription plans.
Very good. Thank you, John. Thank you for all that demonstration. And aside of that, of the technical side of the updates and the ISO discussions, there's also another update done to the software, which is subscription plans. Through our experience and the client feedback, we have now distilled into 3 subscription plans, which you will see is there. We have a freemium, a Yacht Designer, and a Composite Designer, which we feel is the best way to serve our market and our clients. So the freemium allows the user to really explore the basics of the software and will always remain available to anyone who signs up for an account free of charge. Of course, there are some limitations to what that subscription plan can do and how much freedom you have. On the Yacht Designer one, is more meant for naval architects and naval engineers to, of course, validate their structures, explore their cases, and of course reduce the amount of time that they have to spend on FEA when it's really not needed to do simple checks or design iterations or even the ISO checks. This subscription has slightly less degrees of freedom than the Composite Designer because it cannot analyze the most complex structures and geometries, but it does include the YACHTScant module as part of the subscription plan. On the Composite Designer, this really gives access to the complete suite and has the most degrees of freedom and therefore the processing power, but it does not include the YACHTScant by default because some of those users are not into designing yachts or vessels, but more into parts or different structures. So obviously these plans have different pricings and options and add-ons. So I would really recommend to take a look at our website and compare those. If you hit the subscription button before you commit to anything, you will have a similar table than what you see here on the background with all the ins and outs of each subscription plan. So I don't want to clutter the meeting or the webinar too much with this part. But as part of our subscriptions, we do offer the support and training. One of them being these webinars and different recordings. Also video tutorials explaining the basics and also the advanced ways of using the software. We also have responsive support. This means on-demand checks for questions and maybe some challenges that you meet while using the software, meshing surfaces and all kinds of things. So our team is happy to help out to resolve those. There's the option to have some dedicated training, which is more into how to get your team at a certain level to use CompoSIDE, or how to streamline workflows or implement workflows so that they work, so that the software really works in the best possible way for you. Engineering services maybe is the most far-fetched side, where obviously if there is a need for Struct team to step in and support your team to develop the structures, or to technically discuss what is the best way to solve a problem or analyze a problem, and what kind of assumptions there are, then obviously we are keen to offer our engineering services as well. Before I forget, there on the top you can see the link to the YouTube channel of CompoSIDE. Of CompoSIDE to access all those webinars and recordings. I see there we are. I think we have a few more minutes to answer some questions. Also a few more minutes for you to submit your questions. I see a few of them already coming up, but please think about what else you would like to know at this point. Please share that in the Q&A panel on the top side of your screen. You can open a window to the right, and there you can type in your question. It will be visible for us, and then we can see how to answer those. Let's see here. By the way, as you see now on the screen, there are different ways to contact us depending on your question. Of how to contact us on the support or the sales side. So I see here a few questions coming up. I will select a few, read them out loud, and then one of us will answer. So one that I see. Oh yeah, this one's good because I see that coming more often, also outside of this webinar. Questioning: can I work with ISO12215 Part 7 for multi-hulls in CompoSIDE? Marion, maybe you're the best to answer that.
So the multi-hull rule is currently being implemented, but has not been implemented yet in CompoSIDE. Having said that, if you can derive the pressure for a panel of a multi-hull, then you can manually enter the pressure within YACHTScant, and you can analyze your panel and your beams as you would do for the monohull. So it is currently require you to derive your pressure separately, but we are developing the multi-hull. So that will be available fully later.
Yeah, I think that's worth mentioning. It's on our priority list to develop it further. Obviously, it would be best for CompoSIDE to deal with monohulls like it does now, but also with multi-hulls, to have everything in place and automated. The multi-hull rule is quite more complicated, and it does need quite some adjustment to the software. So it is in our to-do list to follow up on. But as Marion now mentions, there is a workaround with the current CompoSIDE, which you can use very well, and I'm sure many of you can easily take on while the software is improved and developed to allow multi-hulls. I see another one coming here on the screen, which is saying, can you import a 3D model straight into CompoSIDE? John, maybe an easy one for you as well.
Yeah, so in terms of FESpace, you can import a step file into CompoSIDE directly. Depending on your package, the size of the model may be limited for the Yacht Designer, but for the Composite Designer, it's a lot more open. In terms of geometry import into YACHTScant, we are working on that at the moment. We used to have a CATIA to YACHTScant import tool, which we need to work on and develop further to make it a bit more user friendly.
Okay, that's great. I hope that answers that question, of course. Let me just browse through here. So maybe in that same line, it's mentioning, how can I pass the information to my reviewer for approval? Let's say a notified body, I can imagine in this situation. John, I think you covered that a bit in the presentation. Maybe elaborate on that.
Yeah, so there's a few ways you can do it. Either you can pass them a YACHTScant report. The other alternative is that you give your reviewer a read-only user in your environment, so they can go into your environment, dig through your material properties, dig through your laminates and your panels to make sure that they're happy with your structure.
Okay, that's very good. That's very good indeed. So that I think it's worth to highlight that idea. I know that you could add more users to your environment. Actually, you could add as many as you like. There is some restriction into how many simultaneous users you can have using the software. But in general, you could just add many users, and also people outside your organization who might be able to then review, and you can select how much or which projects they can see. Okay, let's see another one. So yeah, this one is quite on the details, but I think Marian, you spoke about it earlier as well. How do those coefficients compare from 2008 rules to 2019?
Yeah. Yes. So on the 2008 rule, where the shear coefficient was derived was on the optimist side, and that's one of the reasons why the ISO committee has reviewed and changed a formula for the ISO 2019. So we've moved from being from quite often being too optimistic approach to being a too conservative approach, where obviously the FEA fit within the middle.
Mm-hmm. This is why we also collaborate with 3A to be more and more informed on that. I'm happy to follow up the discussion and have more in-depth analysis on this together. This one I like, maybe because of the practicality behind it, and what I've seen previously, is I noticed 12215 includes the option for analysis of outboard motors. How does CompoSIDE work with these? John, I think you will relate to this one as well.
Yep, I've noticed that in the rules as well. At the moment, we're focused on giving scantling analysis for hull pressures. Our next focus is the multi-hulls. If there's enough demand for generation of loads on outboard motors or from outboard motors, then that's something that we can look at. But at the moment, it's not really in our plans.
Okay, good. At least I think that gives an explanation how it is. I see a few more coming up. Let's see if we can answer those. Give me a second.
Okay, so what is the current method of defining panels in YACHTScant? Manual entry, or there are 2D, 3D drawing tools similar to the buttons currently shown at the bottom of the screen. So in YACHTScant, it's purely numerical. It's the same as every other ISO software, whether it's a spreadsheet or one of our competitors. Yeah, I don't think there's much more to say on that. If you're doing FE analysis, you can use the 2D or 3D drawing tools shown on the screen at the moment.
Yeah, I think it's also worth mentioning that CompoSIDE is not only, let's say, it goes quite a few steps beyond only the certification or the documentation that you would need to submit an ISO approval. It's actually also for designing in it, which is why, like you mentioned, there are some tools embedded in the software to create geometries and to work to generate those models. But that is not directly linked to YACHTScant. YACHTScant is really to pass the rules. Let's not forget that many other of our users also work outside of ISO or with different standards to develop very different structures. Maybe something you can see there on the background as well, more in terms of renewables and other industries. Okay. I hope that answers those questions. We're nearing the end of our presentation and also nearing the time slot that we have. If there are any more questions, this would be the time to submit them. Okay, I think then we can close the session in a minute. I don't see any more questions showing up. So I would like to thank you all for listening. I hope it was all clear, and I hope all of you can follow up after this this webinar. If there are any questions, here are the addresses to reach us. And please have a look at that YouTube channel, because there's a lot of content there from previous years, since 2014, 15, where the software started, and many tutorials have been written. Also, a lot of subjects have been covered about scantling and about yacht design, but also on parts and composite subjects, which CompoSIDE can help out with. So, okay, thanks you all for joining. And I look forward to catching up with you later on in the near future. Thank you very much.
Thanks, everyone.
Thank you, everyone.